Okay, nearly there. Final session. Everyone's awake after coffee and so on. So this final session, we're going to talk a bit about the model repository and publishing models. Just start, I'll give a very, very brief and random overview of where we're at. And then you're just going to talk about some of the workings of searching. And then Alan's going to show us some of the cool stuff happening on the Spark portal that we may want to link in, but it's weather dependent. So you may or may not present. Happy. And then Tommy's going to talk about some of the ideas on where we're going in terms of moving forward. And if time permits, we can have a discussion about some of the features that people need in the repository. So, if you haven't seen it before, hopefully if I'm sharing the right window, this is PMR, models.physioproject.org. There's still a lot of references around to models.cellml.org, which works and will presumably always continue to work. Systems are quite robust, but generally we encourage people to use models.physioproject.org as the URL. And if you go here, what you can see, assuming there might be people that have never looked at it before. So the first thing, you can log in, anyone can create an account. It's 50-50 whether the University of Auckland will block the email that says, here's how you set your password.
It will actually block the first one. I did some testing, it does block the first one because they have a gray listing from the link that you got, the mail, whatever.
The mail spam.
Yeah. So it's part of that system. So they have gray listing right now, which basically means that your email is going to come in 5 minutes, not instantly.
Yeah. So just keep waiting, and you'll hopefully basically when you create an account, you need to get an email from the repository to prove it's you, and that will let you set your login password and create an account. But anyone should be able to create an account. Models.physioproject.org is the main one. That's the public one, and anything you put there will be there forever. So it's something to remember. We can hide things, but it's basically there forever. To go with that, we have and so teaching.physioproject.org is essentially a copy of the repository at some point. It's mostly the same functionality, but this is pretty arbitrary. At random points in time, it all gets deleted and repopulated from the production models.physioproject.org. Accounts will be copied across, so if you already have one on the production one, it'll get copied, but it depends when that copy happens. So you may need to create a separate account, or you might just
in 3 years. So it's been diverse quite a lot.
So you're free to, essentially create other accounts to test things out, but otherwise it's essentially the same. So you can have a play, and there's documentation that will show you how to copy from teaching to production, if you like. And if you're using OpenCore, linking to PMR, OpenCore will let you choose whether you want the production or teaching, or the third one, staging, which is more for testing software. So you might normally use that one as a user.
You could, if you want to things that don't stick around, you just want to test the thing out and then want to go for it eventually.
Eventually going for it. Yeah. Okay. So then in PMR, there's a few favorable categories, and there's very structured way to get things added to these categories, and it's always changing. But essentially, there's ways to browse, there's the set of models that have been published. All of this you can do through the browser or through REST API. I think it's safe to say. And it's all content negotiation stuff. So if you know about web programming, everything you can do through the browser, you can do through code.
How to do it? You go through documentation.
Yeah, there's actually documentation. So if you go here, just because we're never really sure where things are going to live, documentation actually sits separately. And every now and then we tweak it. And one of the important ones is the quick start guides, which basically is the thing people most often want to do, is add a new model to the repository. So it's the steps there, they're probably a little bit out of date, but correct. So then in PMR, if we go to any particular one, most of these are CellML models. We're starting to get other types of models and other things like CellML, but generally it's CellML models. And you can see for a given CellML model, there's different views. So if you want to just check the math to see what a model might have before you decide to use it, do that. It's a little bit slower, but essentially then you get a nice rendering of the math that should be very similar to what you see before. And then for every model, or so in PMR, there's two things: there's exposures and there's workspaces. So by default, when you want to publish a model, you're really making an exposure. You're saying, here's a version of my work that I want to make public, and that'll make an exposure. Over time, the URLs for these have changed and evolved. So older ones have these big long numbers, newer ones have much shorter, more compact URLs. But essentially, this exposure is telling you here that it's linked to this workspace at this change set. So it gives you a very direct link back to the source to say this is where it came from. And essentially, if you look at a workspace, if there's an exposure, you can see it. You basically browse the files. Each workspace is a Git repository, so you can just clone it like normal using the URL it gives you here. And again, these things have evolved over time, so there's slightly different URLs for newer workspaces. You can check the history of a model, and you can see in this case, this was the most recent exposure, but there's been some changes made since then by curators that haven't been reflected, so probably haven't changed in the exposure. And then of course you can search by the type. You can search and you see, oh, there's a whole bunch of different versions of what you can't see. Model, obviously one response is best. And so what you can see in this one is there's other ways you can structure your exposure if you know what you're doing, and do a few tricks. And so you can link, in this case, to a very specific file within the workspace, and that will resolve through to the correct version and all that for this particular exposure. Read. So in this case, saying here's a model, here's some parameters, here's the model with a stimulus applied, and here's a CellML description of it, so you can jump straight in. If you wanted to, you can copy and paste that URL into open4, see what happens. Get it back up here. A bit of a tutorial for this one, explaining how this modular version of Hodgkin and Huxley was put together. Bit of description. So all of this can be done through PMR if you know exactly what you're doing. In various places, it will link to the relevant CellML model within this workspace as this version, so you can navigate it. Clearly, this is not so easy for other people besides Andre to do, with a lot of asking Tommy questions as you go. So one of the things we're keen to do is to enable people to do this type of documentation to go with their work, but in a way that's much easier. Part of the goal. Is there anything else I wanted to say? No. So I think Ellen will talk a bit more about some of the stuff we were linking between PMR and stuff. So essentially in the repository, there's ways you can do your work, you can share your workspaces, you can all work on, collaboratively to develop things. When you're ready to say, here's a version that's good, you can make an exposure and you can make it public, so other people can see it. And that makes it there, it's available for reuse. And we all know that over time, people haven't done that a lot. And so that's partly why the Physium Journal was created, to encourage people and to reward people for doing this. So journal.physiumproject.org will take you to the journal. There's information, you can see a nice little animation of what we're doing. And then here you can see a list of the latest articles, also the only articles. And so, as we saw before, you can get to Nina's model. And so here, what we're doing now is essentially taking it a step further. So we're taking what would be is an exposure in PMR to say, here's a very specific version of this piece of work. And now we're putting it into an external repository. In the case of Figshare, in the case of the journal, we use Figshare to do this. And as that, we're publishing it with a description as a Physium Journal article. From the submission, we can pull out some of that information and display it here in the website. And we need to improve what we're doing there. And then through, and you can see here now is the article on Figshare. So physium.figshare.com. And as we saw before, you get the article itself, which is a PDF description, and the omics archive describing all the files. So if we look, syncing. So essentially you can read through the PDF. It's carefully describe exactly how this article that was published in a normal scientific journal in a normal way, how the model was actually constructed, and how to reproduce the results that were presented. Despite those errors that CellML will now find, the model clearly works and reproduces the results from the framing paper. So another thing that I think is interesting to think about is how we can go from doing your work in PMR to now publishing it as a Physium article without having to do a lot of manual tweaking. And the actual submission system for Physium articles, which is not yet publicly available. There is no submit button yet. So essentially, you need to know how to get there. But as part of the submission system, you can just link directly to your workspace and PMR. That's by far the easiest way for us to get things. As we find, it's not always the way people want to provide it. So I think that's probably enough for me. I think it's more interesting to look at the future. So unless anyone has any questions, we can move on. There are a couple of users up to with some searching and see where things go. Break.
Yeah.
One second.
So I will talk about improving search in MR. And yeah, we already conduct survey in the late of 2019 until the early of 2020. And then based on the survey, we get information that most of users have a particular biomedical domain of interest when searching for information in DMR, and then a particular biophysical mechanism of interest. And then the most suitable path on retrieve page are model structure, model status, and schematic diagram and picture. And the other one, the most suitable link on retrieve page is generated code, and then mathematics, where we assume that it's related with variable, and then model curation and source view. And that's why we have a goal to create an aggregated search. So the interface, if you see on the left side, the interface is kind of a Google search results, and there are vertical search there or aggregated search there. So you can see that there are models and then images, maths, and simulation. So that's the goal. So for example, we have a query, for example, like this, the one query, and then it will be identify the intention of the query, and then after that will be populate into suitable search service, such as whether it's go to models, images, model entities, mathematics, and so on. But all of these rely on semantic annotation because, for example, to locate the correct variables, the variables should be already well annotated to ontology classes. And therefore, now we develop two tools, NLIMAC and BMSE. The NLIMAC is a natural language interface for model entities discovery, searching for any entities annotated to ontology classes. For example, models can be components or variables, can be anything that already annotated with ontology classes. And it utilizing Sparkle, but because Sparkle is quite difficult, so we convert user query in natural language style to Sparkle and automatically. And then working on PMR and biomodels currently. And the other one is BMSE. This is a biosimulation model search engine. It is search for biosimulation results, can be graph generated by CellML, and then math or variable. And then the indexing text features is from class ontologies and PMR, and working on CellML, omics, and CellML. So it's basically extract information from CellML, omics, and CellML. So this is the case in NLIMAC. We have entities, for example, potassium flux over there, and it is already annotated. So when we need this variable, or we need to retrieve these variables, to be exact, we can create a Sparkle based on the annotation over there. So we have information here, FMA9673, KV, and OPD. We can utilize that. So to retrieve that variables, we should create this sparkle. So in NLI, we convert the query, for example, like this concentration of potassium in the portion of tissue fluid into this sparkle. So that's how NLI might work. And the next one is BMSE. Yes, it is working on CellML, ZML, and OS. So firstly, it's create we extract the simulation results and then creates a lot of index. But currently, we only have index of variables, image, and biosimulation results. And then based on the index, we calculate the similarity between query to the variables or biosimulation results, and then calculate the ranking and present the results. So that's the idea. And now the demo is available. I deploy it on Nectar infrastructure, and then it's already it's also implemented as a GitHub module. So a Python module, so you can get it on GitHub and PP. Okay, now we try. Yeah, this one is the MSE Biosimulation Model Search Engine. For example, if I have query images, for example, like this. So we have two choices here, CellML variables. So for example, for a CellML, yeah, so we will get a list of CellML files, and then if you, for example, you can see which one, you can select which one is suitable for your information needs. And then, for example, if you click this one, yeah, so you can get the CellML graph results. It's already generated, and then variables that are related with the graph, for example, like this one, and all the variable inside the mathematical equations. So it will show all the dependent variables or constants or anything that related. And you can have another information about CellML file that related with the CellML files, for example, like this one, and another file that might be related to the CellML files. So, and if you are looking for variable, it's a little bit different. So now, for example, this one's yeah. Yeah, something like this. So pretty similar, but in some case it will show the image. For example, if you read interesting with the images, and then the equations and all the variables related. So this is the biosimulation model search engine. And the other one is an LI. Let's say we have the same query. So we will see the information, looking for the information in biomodels and PMR. Yeah. So this one, oh, so we only find the information from the PMR. So we have the sparkle, automatically it will generate the sparkle like this, and then retrieve all entities that related. We can try another query, for example, like this. This is the longest one. Yep. Oh, okay. A bit slow. Yeah. Okay. Oh, it is only on biomodels, and yeah, we got 5 entities, and yeah, it's generated for Sparkle. Yeah, I think that's all. Any questions? Yeah, I wish that the CellML can be accessed 1 year ago. It will be easier for me to validate this CellML.
In your query, do you have to find all the things by notes at all? Can you just say, for instance, simply versions of whatever?
Which one?
I mean, in your query field, you type find all the things.
Yeah.
Models, etc.
So that's
But I guess you could easily
yeah.
write
So
versions of these or versions of
yeah.
that.
This one is the example from John. Yeah, I just copy and
Yeah.
Or generic.
Yeah. So it's that simply can be shorter. Yeah.
It's just trying to see how to break up the English phrase. It starts to show how you can use the common metadata standards to now search across UMAS. So this is searching not biomodels to repository, but an export of curated models of biomodels that have been converted to the Omics metadata specification. It's essentially model exchange. Questions? Check outside. It's like I want to be able to present.
Not ideal.
Yeah, do with
I was going to tell us all about the Spark portal, some of the cool stuff that we want to use.
So that's the my screen. Super cool. So hi everyone, my name is Alan. So today I'm going to talk to you about the Spark portal. So what is Spark portal? What is Spark first? If you are not familiar with it, it is a big project funded by and supported by NIH Common Fund. It aims to improve our understanding on web forming. You can see on the slide. And so there are a lot of people doing researches, have done it or are doing researches to add to the database that we have, to provide us with data sets, computational studies, maps, and lots of information about what we want to know about the maps. And at the end, with this new understanding, we want to use that to help us to define new medical devices. So that's what Spark aims to do. So in the ABI, we have a big team. I don't know how many people exactly, but between 20 to 30 people working, and we are under this called Map Core, led by Peter, Professor Peter Hunter, and managed by Peter, Andre, and Dana. And what we do here, so we have the mapping team who actually collaborate with many different groups from outside of Auckland, most of them in the USA, to annotate data to create 2D and 3D scaffolds. So, and what we also do is to divide tools to visualize the data. So how do we do that? We need a place to host our data and to let people explore this data. So we have Spark Portal. So Spark Portal is a website where we have connections of digital resources, data sets, 2D maps, and 3D maps. And in the very near future, hopefully you can start running simulations on it as well. And it also provide you with lots of information with the collaborators, and providing software tools for you to start doing your own research as well. And thanks to Sonia, who monitor and work on the documentations, so you should be able to find information about all these tools, about all this information relatively easy. So yeah, at the end, all this is to aim to encourage collaboration between researchers and industries, people from the industries. So maybe I should show you about the portal now. Here you go. So this is the portal website, spark.science. It's a pretty cool looking homepage telling you what this is all about. You can find data by category and like that. I'm not going to show you that. I'm going to first go to the find data page. And here you will find a number of data sets. At this moment, there are 87. More and more are coming to life into the portal as we annotate and curate more and more data. So let's say if I search for heart, this should do a comprehensive search, and this should show some information. So there are all these different data. You can click on them to show you to the details. It will give you the description. So you can find the various information regarding the data set. You can get the citations, the information about the publication, and also you can, if you want to, you can actually download all the data as well. And then we go back. Search for hardware. And just now I was talking about genetic scaffold, talking about 3D scaffolds. It is also possible to look at the 3D scaffolds as well. So if I go to the genetic big part scaffold here, and then go to the gallery. At this moment, we have, you can see that there is a picture. This indicates that it's a 3D scaffold. So Hugh has something working, and it's on the staging, not staging, but it's on development side that will allow you, give you more information about what this is. But because I work on this for so long, I know this 3D scaffold. For you, probably not so obvious, just from that single picture itself. So you will be able to see the 3D scaffold. And then you can play around with it. At this moment, it doesn't really give you much context on what this is. So the next big improvement that we are aiming for is to provide more information about what you're looking at. You can play around with it at this moment. That's all it does, but this will be changed and it will be much more meaningful in the future very soon. And another thing that we do here is the 3D fragments. So I go to the next page, and you can see that here is a fragment of the wet. So paper books and Lex spend a lot of time annotating the fragment and creating the connecting all the relevant information to create this tile set. So you can zoom in. There's a lot of things that you can do with. You can have a look. You can change the different species, and if you click on this marker, what it does is it will pop up for cyber. There you go, and it will bring you search result as well. So what we can do now is we can scroll around, have a look at them. If you want, you can click on View Dataset, and you will open into the page where you can find the relevant information. Just like what we see before. And then you can also go to View Scaffold, and you'll bring up the 3D scaffold, showing you the ICN here. So once again, same as before, once we move on to the next version, you should be able to see a lot more information on this window. And you can also build a plot or search for a heat map or some data set. So you may ask, how does this information get populated onto the website? So at this moment, we are using this platform called Dragon, and now, well, it's called Pencil. So what the researchers do is, what they do is upload their whole data set, whole data onto here, and then a team from UCSD Cypher, they will curate the data, and once they curate it and update their knowledge base, all this data will be available for you to build here. And what we do here, and also if the data set contains a lot of images, we work with this group in US called MBF, and they will annotate the data on the image, and the mappers here will work on creating the corresponding 3D scaffold and also 2D scaffold, depending on what sort of data it is, so that all this information will be available on this data set as well. So how does PML come into this? So for all the 3D scaffold and 2D scaffold that you see, they actually live in PMR, and these are web fragment repository on resources on PMR. And what happens is when you put up the server to create the flag map, to serve the flag map, it will generate the flag map based on these repositories that provided here. Exposure. Yeah, once the exposure. And if I click on the latest exposure, it's so good. I think that you can see exactly the same flag map there. So this is really good. And also for the 3D scaffolds, we also have all the data in there as well. Sorry, just the Zoom interface overlapping for my head. Oops. So this is one of the scaffold there that is that got published onto PML Exposure So what I think in the future, what will be really powerful is that you can just download all these exposures if you're interested, and get them imported into our map time tool that hopefully will support generating all these scaffold relations. Then you can start doing your own research, creating your own scaffold, changing parameters, everything. If you're interested, all these will be available for you and for anyone to use. And another thing that we are working on, thanks to Alan and Jesse, is the simulation viewer that is going to be implemented and hopefully live very soon. So if I go to Map, so these are the final version of the portal. If I click on the at this moment, all this is hard coded on this page, and you can click on the full simulation. You can just play around with it. You can change this value, and then you can say one simulation. So you hopefully in the future you will be able to run the simulations of that data set if there is a simulation for you to run. Hopefully, well, you will be on CellML models. But what needs to happen first is that all this metadata, all this the relevant information need to be imported into the knowledge base. And I think Tom is working with the CSD to get that happen. And once that happens, we will be able to get the exposure from PMR, hopefully. And then hopefully we can also run the simulation in the portal. That's the aim. We'll see how that goes, but I think it will be a very powerful tool. So I think, yeah, I can cover that. Okay. So that's all for now. A lot of developments are going at this moment, so the portal is changing every week. Well, and every 6 weeks we do a release on the production side. So you may find something different. You will find data, and a lot of cool things is going to happen very soon. Thank you so much for working on this project. It's wonderful to work with all these people. And thanks so much for NIH for providing the funding. And Peter, for the opportunity for me to work on this. It's been really fun. Yeah. Cool.
You still have 1 month to go.
Hey, sorry.
Lucky, you still have 1 more year to go.
Yes. Are there any questions?
If you go to the PMR site, what should you search on to find the evidence?
The flag map. Oh, you okay. I can show you. So I go to the top right here. Just say flag map. Probably got this all sorted, and then I go to the web flag map here. Search result. And then you go to the latest exposure. Then you show the- there.
So I mean, this starts to show us the sorts of interfaces. And for those that have looked at CellML models for a long time, those nice little diagrams of the cells, you can imagine the same sort of thing with that kind of flat map interface. Connected to the semantics, tying it all together, linking all these different resources together. So close, so close, so close.
Yeah, well, I think we are just building on the infrastructure now. So once we are just getting into pieces of the puzzle together, And then at the end, I think it will be a very powerful tool. And hopefully it will be minimal amount of work for people to publish their data and to get everything's working together.
Of course, anyone apart from people who work on Mapcore wanting to build on that infrastructure to make cool projects, Spark their codeathon, looking for projects.
$10,000.
$10,000.
US dollars, not percent dollars.
US dollars.
Been looking on it.
And then you have to pay taxes.
Surprise.
The top prices depend on me.
Oh, Tommy's got an extra laptop. Okay. So now, I think we have to I don't know, Tommy's stuck with it.
I stuck with it.
Talking about Rusty CLR, and some of the work he's been thinking of going forward.
Much of the slides actually didn't cover biology talks, but we'll go over it. You know who I am. That's been covered earlier. You know what works exposures are, I'm sure. And then the web service, if you want, as I mentioned before, it's documented. People have tried it, such as the group earlier, the Julia, because they use web service to download models, and we're using like them anyway. And skip that too. Anyway, the new feature that Alan's demonstrated is the flat map thing. We just brought it online. And the other thing that we also worked on, which kind of got scrapped, but it's still there. It's the metadata exposure for given exposures, so that any metadata associated for the given CellML file or the model can be exposed as a standalone JSON or RDF document. The 3D scaffold viewer should be coming. And we had that stage for quite some time, but I never got it deployed to production. So that exposure, we can probably get the viewer on soon. But speaking of Rusty, PMR is built on top of 4, which in terms is built on top of 2.7, and as you all know, 2.7 is deprecated for some time now. There was an effort to migrate, but the issue was that 0.5 has a bit of complications with how they deal with JavaScript, and it makes it rather difficult to do testing and clean UI components, and also the way that is usable across the server and the client side. And so, and also it's a much steeper learning curve for other developers to get in. Yuda did an amazing thing integrating a new component PMR some time ago for the search survey, which was pretty awesome. But your experience wasn't that straightforward, or was it actually straightforward with Home 4? I'm putting you on the spot.
Yeah, I tried to create a survey.
Yeah, the survey thing.
Yeah.
So how do you find the process?
It's not that difficult.
It's not that difficult, but like 0.5 has changed some things, and it is easy in some ways, but now that you got, for instance, with the portal, it's a lot of front end, client side rendering. It's the way 0.5 structure doesn't, like, they are trying to improve it, but it was during the weird time when Python and JavaScript they try to make two language coexist together without really defining a formal way to do so. And I tried with another different package that I wrote called JS, but that's not without issues. But anyway, I find that annoying, as the talk earlier by Anand And yeah, so my apologies if they're still here. The two language problem is actually a very difficult thing to solve. And so, especially when you're coupled with like all of these other different frameworks, it actually drives me quite mental. So what I actually been thinking about is modeling PMR. Like we talk about building models like CellML models, like, but PMR itself can be considered a model. Like how do you like think of like presenting things like a repository? So the idea is to bring together the core concepts that we already have, formalize them into some kind of relation model. So rather than building it on top of frameworks that seemingly would yank the carpet right underneath my feet, I would rather build something that is build it on something that's more stable and more persistent and more with actual guarantees that it will continue to work many years from now. And of course, given that Git has actually stayed stable, so that's a good technology that we fortunately picked. So we're going to keep using that. And the core concepts that we have, such as workspaces, exposures, are going to keep because these are very useful concepts to present the data models or other work in the repository. And speaking of Rust, yes, there's language for Rust. I built a prototype on Rust. It's still a proof of concept. Don't really have anything to show right now, aside from that. And a bit more about Git. I know I'm bouncing all over the place. Anyway, the issue is that we have built the Git interface currently on PMR many years ago, before, well, GitHub was around, but before GitHub became popular, before people realized that pull requests are awesome. You got all these issue trackers are coupled in, like people want these capabilities in PMR in the Git repository, but we're just not really capable of providing all that with a development team with a size of one, which is me. So instance, but fortunately Git's distributed. We could just rely on external repositories like GitLab, GitHub. Sure, we can install GitLab, but installing it is a bit of a pain. So, but we could run our instance should we choose to, but people are free to do whatever they want because Git is distributed, as I said, repeating myself. And a bit about Rust. It's a language initially developed by Mozilla to basically make it a safe language to build Mozilla Firefox on. Because Firefox had been driven by memory state issue, which turns out you get like remote code exploits, which is bad. So they basically built a language to eliminate those problems. And since it's designed to replace C, it basically is also a compiled language with very strict typing and actually performs very quickly, performs great. Much better than Python. Python's an interpretive language, and it's but even so, it is possible to integrate with Python through packages like PYO3 bidirectionally. So you could embed Python, or rather you could from Rust, you could call Python, or you could export your Rust code into a Python package. So it's like this nice bidirectional thing. And also another thing about Rust is that it's very easy to target WASM, which is the next web language scripting, not really scripting, but like the client-side environment standard for web browsers. And this eliminates the double language problem. Now you don't have to, I was worrying about how to integrate JavaScript with Python, but now we don't really have to worry about it because you can just do everything in Rust. And about the stable foundation, Rust has the concept of edition, so that they make guarantees like every 3 years you can come up with a new edition that any language features that a developer has targeted for an existing edition won't suddenly change because they don't make this guarantee, but they're going to make this guarantee. So it means any code I write or any developer writes or creates for a particular edition should continue to work basically in perpetuity. So that's good, solid foundation buildings on. Anyway, that's all I have. Any questions or discussion time?
Tell me, what's the timeline now for getting the 3D viewer back into?
I could bring it in because like all the things ready, I will have to do another staging because I think I just found an issue with the most recent staging that I did. The code should be ready. We could try it out. I could probably get it done this week if we really need it.
Just maybe in terms of going forward and looking at wanting to put more cool stuff into the museum journal.
Yeah. Oh yeah.
Do you see us sharing modules, something between what goes into
Oh, yeah.
VMR and what goes into the journal?
Like that's the idea. Like one of the things I want to build for this foundation is that if we have a model of how PMR works, we could effectively take that and then stick it into other things. So kind of like the PMR, like little or stuff or whatever. That's still a bit nebulous plan right now because I just only started thinking about it in earnest early this year. So.
And you thinking mostly in terms of like the back end modules and stuff, and then
Yeah, basically design some kind of protocol also to communicate PMR or rather to present the data in PMR through like some kind of similar thing which can turn the web service. So like developers, if they choose to, they can just integrate, they can run a local copy of PMR that only deals with web service stuff, and they can communicate to it with JSON or whatever it is.
Tell me, are there other examples of converting from client to Rust?
Not really. It would be like the thing is this would be a completely different redesign because also the Plum developers, what I was seeing doing, I actually have no idea lately, but there was a big rumor about them basically ditching Python altogether. Not sure, like they might end up going JavaScript because they might still have the core. That is because they also have a concept of headless Plum, which is a Plum model effectively. But then all the front end stuff can, which has the advantage of interfacing with modern front end JavaScript rendering things in just React or Vue, whatever, Angular, which is actually what a lot of things that is good, but it removes a lot of the server-side rendering capabilities that we have been depending on. So it basically, and server-side rendering, aside from Google, most search engines basically can't see that, which is not quite useful for us.
How big is the Rust community? I mean, I just guess I'm trying to get at the risk associated with it.
Oh, Rust is currently adopted by Amazon, Microsoft, Google. Basically, all the big major companies out there are very deeply invested in Rust right now. So it isn't going away. And Rust has recently created a separate foundation to deal with funding, which is being sponsored by, again, those big companies. So it isn't going away because they have mostly detached themselves from Mozilla. As you know, Mozilla has gone through certain staffing and funding issues. They had to fire a bunch of people because I will not get into that side of things. But because it makes me a little angry, but at the very least, the Rust is seemingly in good hands with their funding and the developers being able to keep working on it.
But we had Carl from API was working from Mozilla. Is he still going to do it?
I think he still works on the
Yeah. Because it is yeah, because it's just a certain management within Mozilla deciding, hey, I'll shut up. That's all right. Yeah.
I remember a few years ago we were talking. Some people were talking about Scala, etc. I mean, What I think what Peter may be
Yeah.
into is why this make it the most local,
Well, the reason I think, like, if we want to digress a bit to talk about Scala, there is a reason why Scala community died. There is a reason, like, because they never put any focus on proper inclusive community building. Whereas Rust spent a lot of time doing inclusive community building, such that people feel they're welcome, their contributions are welcome, and they have a friendly community. Scala was rather exclusive. I don't want to say too much new things right now. But the thing was, Scala also, the issue with Scala was that if we were looking purely technical side, was that it's built on top of a JVM, which is fully controlled by Oracle, and Oracle does things to technology stacks they have acquired by basically covering it with a bunch of lawyers. So that's another way that kind of strangled
I
it.
think I just triggered this.
You have, but that's
So
okay.
I think, I mean, the other side of this is also thinking as the PMR model
Yes.
and the sort of extraction of that. To some extent, I think separates us from the implementation of that model in any particular language. So, you know, obviously Rust, I think is very popular.
Yep.
It seems pretty stable.
Because
It's gonna be around. I think that sort of infrastructure.
yeah, because one of the things I am doing is creating a relational database model for what's PML about. So I have effectively SQL tables that relates workspaces, change sets, and exposures, which is something that I'm slowly building up on, make sure that it all makes sense in my head, and then it makes sense actually, and then yeah. Yes.
So what parts of the PMR software do you call this language?
Basically, Python can be quite annoying when it comes to doing like parallel asynchronous stuff because of the global interpreter block. Because like right now, there are ways that SOAP kind of gets around it, but I am running into weird issues when I try to integrate with other web servers because of how we're talking. But I mean, it's more like the current architecture is quite restrictive with how things are done. But whereas the Rust is more properly designed to deal with multi-threading or asynchronous code execution and all that stuff.
Right, so all of the people wanting to use the same repository at the same time, just managing all of this requests, that's sort of.
Well, one thing that I have to consider for the model is that how am I going to determine the uniqueness of a repository? Like, how do we, like, if we want to combine two different repositories together, how am I do it? Like, this is something that I'm thinking about. So, but like, this is not so much a performance issue, but more like a modeling issue, which is like what I mean by modeling PMR. Like, how should we approach this? Sorry, I digressed a bit here.
So, I mean, one of the other things to consider, and I really thought a lot about this, but essentially PMR, has somewhere around 1,000 models with a minute persistent URIs that we want to keep forever.
Yeah.
How do we migrate to a new framework?
We've done that before with the CellML repository. If you were to go to any publication that use CellML.org/models, say Clear Router 1977 _version 01 _variant 01, whatever it is, I can't remember. Those links will actually give you back a page. So we will have to come up with, we will have a plan to do this at work, at least I will, but that's how we have to, because in order for a scientific repository to actually be a scientific repository, it has to actually work. Forever. So these links must lead to somewhere. So when it is time, if we actually get to that point where we're just plan does come to fruition, for say PMR3, it's not going to be called PMR3. It might. No, I should stop that one. Anyway,
It's very different.
sure. Yeah, open PMR anyway. So the links from that are currently hosted on modulus.museumproject.org that leads to an actual workspace, or not sure about workspace, but exposures definitely. There will have to be a redirect of some kind, or some kind of disambiguation page that tells user that, hey, we actually done a migration. Here, this is the new resource you might want to. It depends like what we end up having when we are ready.
Whether we migrate with content further than
Basically,
use some of the new stuff.
potentially, we'll see how we'll see what happens. Because the issue is that sometimes technology stack changes quite a lot. When I'm building something, suddenly I find out it happened more recently, especially doing JavaScript development. Like I built something and then suddenly when I'm done, like, oh yeah, actually the diagram's not there anymore. Like, well, it's still there, but everybody else decided they're now there, so you're not there, which means that interoperability becomes difficult if you want to integrate things. And that's the major reason why this is like developing anything on Node.js or JavaScript. That's a bit preachy, but
When it comes to the REST API, if you were to rewrite in versus about the REST API solutions, because that
yeah, you're currently depending on it. I know OpenCore heavily depends on the current way of collections, JSON collections.
Yeah.
So I will be working with, once we get to that point, we will make a decision on that. I mean, I want to retain that, but it depends on what's actually what we will be doing. But given that's a big enough change, I don't foresee replacing it without any announcement or any warning. So.
And also, say everything is written using REST. But you know, I mean, there are people who may want to target AMIs from Python or whatever. So, is there an easy way to create, say, Python binary?
Yeah, IP103 is a package that will assist me in that. When I get to that point, I will figure that out. But right now, it's still too early to say anything. But it is definitely possible to build Python bindings or include Python code either direction.
Because I mean, I'm just trying to think about LibCellML, for instance, written in C++. People use C++.
Yeah. Well, C and C++ have direct Rust integration anyway, so.
Okay. Oh yeah.
Yeah.
So basically, what you are saying that having a PMR written in Rust, we can use it from Python, WebAssembly,
Yeah.
and from C++.
Yeah.
Because it's also, I mean, currently everyone interacts with PMR, but it's through the bricks of the Sure.
And we really haven't, aside from you, nobody else was adventurous enough to write anything on Paul. Even though we try to get people to, nothing, no other collaborator.
You know, even so, people currently use the REST API. And I'm just thinking about Spark. So they do have a REST API. They also have the Python interface. That's what we are using at this point in time. And that makes it easier to use rather than the REST API directly.
Yeah, but then that's a script that is using the REST API.
Yeah.
Yeah, so we might have some.
It must be, yeah.
I mean, we already got this in PML, there's a package called PML2 client that is basically a route buffer around the current.
Okay.
So. But it just
So-
depends on.
Okay. I'm just trying to.
Yeah.
Okay.
It's good that we think about all
So-
kinds of pitfalls beforehand.
As you know, we are thinking of working on legal framework. So. Some legal framework, that's something that should be written to us.
Well, it's your choice. I personally advocate for Rust, definitely, because I have done Python for basically for the last 14 years since I started working at the API, and I find Rust to be very much at home for me, even though I've been programming Python for all that time. It's a very weird field, but Rust does have a lot of guarantees that it is designed to replace C and C++ in a memory and thread safe manner.
Yeah, well, that's what I'm going to.
Yeah, so like, yeah, if lib open core were to be developed in Rust somehow, yeah, I think I would see that as a pretty big boom to the longevity of the project.
I mean, at the end of the day, I'm not the kind of person who would just jump on a particular wagon simply because Rust is the kind of
Yeah.
trend of the day. I just
Basically.
want something that is, yeah, to use it because it is indeed an improvement.
Yeah.
of the seas of the etc.
And not just that, we are actually seeing a lot of major industry adaptation, unlike Scala, unlike Pascal, unlike insert language that people have advocated heavily before at the API class. Sorry, this got very technical for most people, so apologies. Critiques. That's it.
So just to get back to Michael's question. This morning, when are we going to start commenting on email lists? Having been able to discuss.
Oh, right.
published work.
Probably never. As I mentioned, I am having difficulties trying to get certain stuff working with the crusty old Python 2.7 stuff. Yeah, well, we can think about that. There's a lot of nebulous plans that have not yet come to fruition yet, so take that what you will.
Most of them are definitely-
That's why I can talk so.
Next comment. That's pretty much the end of the program. We have closing remarks, but of course, the organizing will give any closing remarks.
I'll give a couple.
Okay. Can we have a volunteer for
I think there's only two people left, Michael and who aren't here on the call, but I just wanted to say thank you to Andre again for all the effort he puts into these workshops. And the way he runs them is just so great. So let's give him a round.
Cool. I think that's it. Thanks, Edmund, Michael, for hanging around to the end. You'll be pleased to know the rain has just literally started to fall out of the sky in buckets. And we have to walk up to a bus.
It's pouring down here.
Nice, comfy area ride home, I think. So cool. Edmund definitely looks like he's in winter.
It's freezing cold and wet outside. Yeah, so. Nice.
We're in the same bubble. Don't forget.
Okay, well, thanks, everyone. Hopefully things stay nice and healthy and we can have another workshop next year. Fingers crossed. Otherwise, we'll just start packing up. You're going to need to unplug your laptops. And we'll go your ways.